All right, looking at the second page of the one enos. There's four pages on the one enos, but I'm just looking at the second page right now. And I want to look at a few more of these conditional statements and write the converse, inverse, and contrapositive. So let's do that, okay? And so what we're going to do is we're going to write the converses of these two things, and we're going to write the inverses, do those in purple, and then we'll write the contrapositives and do those in pink, okay? All right, so starting here on this one, if your car runs out of gas and the car won't work, okay? So converse of that is if the car isn't working or if the car doesn't work, then it ran out of gas. Okay, that would be the converse of that. Okay, I'm writing, kind of getting off the page there. Okay, so if the car doesn't work, then it ran out of gas. Pardon my handwriting. Just make sure you listen and copy down if you need to. Okay, so if we're looking at this conditional down here, if 4x minus 7 equals 21, then x equals 7. Okay, so the converse of that would be if x equals 7, then 4x minus 7 equals 21. Okay, so if x equals 7, then 4x minus 7 equals 21. Try to clean that up a little bit. All right, next, if we go here, we have our conditional if the car runs out of gas and the car doesn't work. Okay, so the inverse of that is, if the car doesn't run out of gas, right, then it works. Now be careful because here we already have won't work there, so we have to negate that. So if it won't work, then it'll work. Okay, so if the car doesn't run out of gas, then it works. Then it'll work. Okay. Down here, the inverse. Okay, so the conditional is if 4x minus 7 equals 21, then x equals 7. So the inverse would be if 4x minus 7 does not equal 21, then x does not equal 7. All right, now we go to the contrapositive. Okay, so if the car runs out of gas and the car won't work, so this one would be if the car works, right? Because doesn't work becomes works, right? If the car works, then it didn't or doesn't ran out of gas, so it didn't run out of gas. Okay, just more practice with those if you need help. Okay, down here, contrapositive. Okay, if x doesn't equal 7, then 4x minus 7 does not equal 21. All right, now what we're going to do is we're going to come off to the side, and we got to determine if these statements are true or false. Okay, and we're going to use this to sort of go to the third page. So if your car runs out of gas and the car won't work, well, that's true. All right, car's got to have gas to work. Okay, so if your car runs out of gas, the car won't work. It's true. Okay, looking at the converse, if the car doesn't work, then it ran out of gas. So if the car doesn't work, then it ran out of gas. Well, I've been driving for 17 years, something like that, and my car's been in the shop many, many times, never for being out of gas. Okay, so that converse is going to be false. Okay, because that statement is saying if the car doesn't work, then it must have ran out of gas. Well, there's a million other ways for cars not to work than just being out of gas, right? So that's false. Okay, third one, inverse. If the car does not run out of gas, then it'll work. If the car does not run out of gas, then it'll work. Well, that statement is saying that, as long as I have a full tank of gas, the car will work. Again, okay, that's false. Okay? Just because you don't run out of gas doesn't necessarily mean your car will work, because there's many other components of a car. Okay? Last one. If the car works, which means the car is running, then it didn't run out of gas. Okay? Well, if the car's running, okay, and if the car's running, then it must have gas in the tank. Okay? Otherwise it wouldn't run. So that's true. Okay? So in this particular instance, okay, the conditional is true, the contrapositive is true, the converse and inverse are false. All right. Now, coming down to this bottom one here. So if 4x minus 7 equals 21, then x equals 7. Okay? Well, if we plug 7 in, 4 times 7 is 28, minus 7 is 21. Okay? So if 4x minus 7 equals 21, then x equals 7, and that's true. Got to be. Okay? 7 is the only thing that can work. Converse, if x equals 7, then 4x minus 7 equals 21. Again, plug 7 in right there. So 4 times 7 is 28, minus 7 is 21. True. If 4x minus 7 is not 21, then x is not equal to 7. Okay? So if we were to choose 4x minus 7 equals any other number, okay? All right? If 4x minus 7 was not equal to 21, okay, well, then it's impossible for x to be 7, okay? Because 7, okay, 7 only works. 4 times 7 minus 7 is 21, okay? So 7 only works. 7 is the only number that works to make that equation equal to 21. So it's true. 4x minus 7 is not 21. X cannot be 7. Okay? And same with the contrapositive. True. Okay, if x is not 7, 4x minus 7 is not 21. Okay? Now, I want to use this thing to go down to the middle of the third page here to talk about a biconditional. Okay, a biconditional. Okay, so coming down here. Now, there's a little bit of a typo here. I should put the word true here. Now, if we have a true conditional with a true converse, that is called a biconditional. Okay? A biconditional. A biconditional is written as P, which is our hypothesis, if and only if Q. Okay? And if and only if we can abbreviate as IFF. Okay? Now, again, this can only happen, ladies and gentlemen, when we have a true conditional and a true converse. Okay? Only with a true conditional and a true converse can we write a biconditional. All right? So if we were to come back up here to our thing right here, right? So our hypothesis part was 4x minus 7 equals 21. That's our P. X equals 7. That's our Q. Okay? That was our hypothesis and conclusion. What we can do is, because we have true and true right there, we could write this as a biconditional, okay? Which means 4x minus 7 equals 21 if and only if x equals 7. If and only if x equals 7. Okay? Because there's no other way to make 4x minus 7 equal to 21. Okay? So we can write a biconditional here. Because again, we can write a biconditional when we have a true conditional with a true converse. Because really what happens is the conditional and the converse end up sort of being one and the same. Okay? 4x minus 7 equals 21, x equals 7. They're really the same thing. Okay? This says x equals 7 and this says x equals 7. It cannot, the situation is not the same up here. Okay? Because the car running out of gas is not the same thing as the car not working. Okay? Running out of gas is one thing. The car not working is another thing. So if we were to write a biconditional here, which I don't write this on your paper, I'm just going to write this up here as an example, okay? So a biconditional here would be, the car doesn't work if and only if it runs out of gas. Right? That doesn't make any sense, okay? Because it says the only way the car doesn't work is only if you run out of gas, which doesn't make any sense, okay? And we can't write that there because the conditional and the converse are not both true. Since the conditional and the converse are not both true, okay, then we can't write a biconditional. So when we go through and do our true false values here, we can only do a biconditional when our conditional and converse are true. And I want to go to the back page here, and I want to look at a couple of example problems here. All right. We'll skip this for right now, and we'll come back to it. We'll probably just talk about it in class. So we'll skip those 4 problems right there, unless you want to try it out on your own. All right, so I want to look at this first one here and this last one right here. So the conditional, if the angle is 102 degrees, then it is an obtuse angle. Okay? Well, that's true. Okay? If an angle is 102 degrees, then it's an obtuse angle. Okay? The converse would be, and I'm going to abbreviate this thing here. So the converse would be if the angle is obtuse, then it's 102 degrees. If the angle is obtuse, then it's 102 degrees. Well, that's false. Okay? Because if you think of obtuse is anything from, between 90 and above. 90 degrees and above. Above 90 degrees, I should say, right? 90 degrees and above is obtuse, okay? So just because an angle is obtuse does not mean it's 102 degrees. The inverse, okay? The inverse would be if it's not 102 degrees, then it's not obtuse. So if it's not 102 degrees, then it's not obtuse. True or false? Well, hopefully we said false. Okay, just because it's not 102 doesn't mean it's not obtuse, because think about this. 101 degrees, that's not 102. Okay, 101 degrees is not 102. But it doesn't mean it's not obtuse. So this statement, if it's not 102, then it's not obtuse, is false. Okay? Because this statement is basically saying that the only obtuse angle there is there's 102 degrees, which is a total lie. Okay? Lastly, the contrapositive, okay, so if it's not obtuse, then it's not 102 degrees. Right? Now, think about it. If it's not obtuse, so if it's not obtuse, okay, if it's not obtuse, that means the angle's got to be 0 to 90 degrees, okay? So not obtuse means it's got to be 0 to 90. Okay, so if it's not obtuse and it's not 102, well, that's true. That's true. Okay. If it's not obtuse means 0 to 90. Okay. If it's 0 to 90, then it cannot be 102. So this statement's true. Okay. So on this one, we cannot write a biconditional here. Okay. Because we have true conditional, false converse. Okay. Can't do it. Let's scroll to the bottom problem here. Okay. If the Cougars score more points than the other team, then the Cougars will win the game. Now, let's pretend that this is not golf. Okay, let's pretend this is football, basketball, baseball, softball, something where more points equals a win, just to make it simple here. So the Cougars score more points than the other team, then the Cougars win the game. That's true, right? If you score more points, you win. Okay, converse. If the Cougars win, then they score more points. Okay, if the Cougars win, then they scored more points. Okay, well, it's true. It's the only way to win. Score more points. Okay, unless it's golf. Now, inverse. If the Cougars don't score more points, then they don't win. If the Cougars don't score more points, then they don't win. Well, that's true, right? We don't score more points and we don't win because winning is scoring more points. Okay. And the contrapositive, okay, if the Cougars don't win, then they didn't score more points. Then they didn't score more points. That's true. True conditional, true converse. Can we write a biconditional? Yes. Okay. The biconditional is the Cougars will win if and only if, okay, IFF is short for that, they score more points. Okay. And again, we could write that because the conditional and the converse are both true. When the conditional and the converse are both true, ladies and gentlemen, it basically means that they are one and the same. Okay. Basically, scoring more points than the other team and winning are really the same thing. Okay. Since scoring more points and winning are the same thing, it's going to make both of these things true, which is going to allow us to write a biconditional for that. Okay. So that's our 1E notes in a nutshell. The rest of them we will discuss in class. So we'll talk about all this, the rest of the stuff, sort of in class here together. But this should help us get the first page done, the second half of this third page right here, and then you could try these two out if you have time. If not, no big deal. All right. Thank you and have a terrific day.